design of this on the left. Now,
Hello students, welcome to my YouTube channel VRacademy. We are here to study about digital electronics. Today's topic of discussion is SR Latch using NAND gate. We have completed the last video where we have gone for SR Latch using NOR gate. So this is the second way to design the SR Latch. We'll be using NAND gate in order to design the SR Latch. We'll try to learn about how it is operated. We'll follow the same process. We'll go for the design first, and then we'll go for its operation, and finally we'll be designing its truth table. Okay, so first thing is how to design a SR latch using NAND gate. So the same process is there. What you will be doing, you will be just having two NAND gates. I mean, SR latch is also designed with the help of two NAND gates only, as in case of NOR. We were also using two. Here also we are using two NAND gates. Okay, so just have two NAND gates. Okay, and I am naming this one as G1, this one as G2 for your convenience. So what you will do, you will extend the first terminal of G1 or the upper terminal of G1, you will extend the lower terminal of G2. After having the extension, the smaller, the other terminal of G1 and the other terminal of G2, you just draw a perpendicular line at the input and the output of that NAND gates. Just put a cross and you will be able to get the design of, SR latch using NAND gate. Now this is your S and this one is R. Just remember this point, student, that when we have drawn it with the help of NOR gate, S was at the bottom, R was at the top. But whenever we are designing it with the help of NAND gate, S will remain at the top, R will remain at the bottom. You do not get confused and do not make mistakes in the examination while drawing the diagram. Now there are two outputs expected as expected. This one is Q and this one is Q bar. Okay, so this is about the design of SR latch using NAND gate. Next, we'll go for its operation, and we know that in order to understand the operation, we have to go for first of all we have to go for writing the Boolean expression, and then we'll go for its operation. I'll consider all the cases. So first, you tell me what will be the Boolean expression for Q. For getting the Boolean expression of Q, one terminal is S, the other terminal is Q bar. So we can write it as S dot Q bar whole bar, S dot Q bar whole bar, and if we are writing it in summation terms, it will be S bar plus Q, S bar plus Q. Similarly for Q bar, I can write it as R dot Q whole bar. That is nothing but R bar plus Q bar. This is our expression 1 and this one is our expression 2. Now once we have got both the expression for Q and Q bar, we'll try to learn about the operation of this one considering all the cases. So operation, we'll go for operation, and we'll start with the first condition, that is case 1. What is case 1? Case 1 is S equals to R equals to 0. This is the first case. S equals to R equals to 0. Now if I'll substitute S equals to R equals to 0 in equation 1 and 2. Just have the substitution of S equals to R equals to 0 in equation 1 and 2. So if I'm substituting it 0, if I'll substitute 0 over here, we'll get 1 because complement of 0 is 1. So 1 plus Q, what we'll get? We'll get Q value equals to 1, isn't it? You can have the simple Boolean algebra analysis. Just put the values, you will get the answer. S bar, so that means 0 bar plus Q. So bar of 0 is equal to 1 plus Q. 1 plus anything will give you 1. So that is the value of Q. Similarly, you will go for Q bar. Q bar is R bar. R bar means 0 bar plus Q bar equals to 1 plus Q bar. 1 plus anything in Boolean algebra will give you 1. So you can see that we are getting both the values as 1. Q is also, we are getting it as 1, and Q bar is also equals to 1. Now Q and Q bar both are equal to 1. Is this a possibility? Complement of any variable cannot be equal to its value of the variable. So therefore we can say that Q and Q bar cannot be equals to 1. Hence this state this state is called forbidden state or intermittent, whatever you want to say, indeterminate state, forbidden state, indeterminate state, anything you can say, that's fine. Okay, so we are not getting any kind of output in this case because 1 and 1 is a contradiction. We cannot get anything, therefore we are telling that this state is forbidden state or indeterminate state. Next we'll go for the case 2. We'll go for case 2. In case of case 2, we'll take s equals to 0, r equals to 1, and we'll substitute that, substituting s equals to 0 and r equals to 1 in equation 1 and 2. Now you can do it by yourself and write answers in the comment box that what you are getting. So if I am writing it over here, q equals to s bar is 0 bar plus q. So 0 bar is what? 1 plus q. Now 1 plus anything will give you 1. So q comes out to be 1. Similarly, we'll go for finding the value of q bar. Q bar is how much? R bar plus q bar. So R bar is 1 bar plus q bar. So 1 bar is 0 plus q bar. 0 plus q bar is q bar. Now since we have got the value of q equals to 1, q bar will be equals to 0. Q bar equals to 0. In the same case, we have got the value as 1. Therefore, we are substituting it and we are getting the value equals to 0. So when s equals to 0, r equals to 1, we are getting q equals to 1 and q equals to 0. And if you can recall from the last class, SR latch using NOR gate, if the output comes out to be 1, we are telling that one as set condition. So this condition is described as set condition. This is your set condition. This is the set condition. Next, we'll go for case 3. This is case 3. Case 3. We'll go for case 3. Once again, we'll put s equals to 1, r equals to 0. Okay. Now, substituting s equals to 1, r equals to 0 in equation 1 and 2. Now, if you are substituting it, let us see what you are getting. Q equals to s bar plus q. S bar is how much? Is 1 bar plus q. 1 bar is equals to 0 plus q. 0 plus q is nothing but q. Let it be. Let it remain as q. We'll find the other value and then we'll see what happens. Now, q bar, what is the value of q bar? It is r bar plus, so r is how much? 0. So 0 bar plus q bar. 0 bar is how much? 1 plus q bar. 1 plus anything is 1. Now you can see that if you have got q bar value equals to 1, in the same state, you will be getting the complement of that, that is 0 over here. So now you can clearly see that we are getting q equals to 0 and q bar equals to 1 when s equals to 1 and r equals to 0. Now this condition is described as reset condition. Reset condition. Now why it is called as reset? Because the output is equals to 0. Q value equals to 0. Now the last condition will go for case 4. Case 4. And in case 4, we'll write s equals to 1, r equals to 1. Now if s equals to r equals to 1, substituting s equals to r equals to 1 in equation 1 and 2. Now just have the substitution and we'll get the answer. So q will be equal to how much? It is s bar plus q. So 0 bar, sorry, it is kind of, sorry, 1 bar plus q. 1 bar is nothing but 0 plus q is same q. Let it be, keep it as it is. Now q bar equals to once again 1 bar plus q bar. 1 bar is nothing but 0 plus q bar equals to q bar. So you can see that q is coming same as q, q bar is coming same as q bar. We are not getting any appropriate answer. But we can see that whatever the value of q remains previously, the same state will come as the output. Whatever value of q bar remains, the same state will come as the output. Now this condition is described as no change state. No change state. Okay, so these are the 4 conditions and the operation related to SR latch using NAND gate. Now, after having this, we'll finally go for designing its truth table. Now, once you are done with the operation, designing of truth table becomes very simple. You will go for S, R, then Q, Q bar, and then here you will write down remarks or comments. Remarks. Okay. 2 input variables are there. How many combinations? 4 combinations. 0011, 01, 01. Okay. Now, if S equals to 0, R equals to 0, at that time, what we are getting? Both the value as 1, 1, which is not possible. Therefore, we are writing that one as forbidden state. Forbidden state. Okay. 0, 1. In case of 0, 1, we are getting the value of Q equals to 1 and this one equals to 0. And this condition is described as set. 1, 0, we are getting 0 and here it is 1. This condition is described as reset. And when we are getting 1, 1, we are getting Q and Q bar, that is nothing but no change. Okay, so I think you have understood the design process and then the mathematical, or you can say the Boolean expression. Once you have understood the Boolean expression, taking the 4 cases, you can have the operation of SR latch, and this is the truth table of SR latch. Now, this is all about your SR latch using NAND gate. If you have any doubt in its operation, you want to understand it in a better way, or if you have any suggestions regarding having the change, you can come up with that. But I think that this is the best method to understand the operation of SR latch. It might not be given in any kind of book or anywhere on the internet. You will be finding out this is a type of analysis which is not done previously. So it is very important to understand this one in this way, and this is the easier way to understand the SR latch using NAND gate. Thank you for joining. Your suggestions are highly recommendable. Thank you.